Hi, I thought I'd try to make a short video to try to explain IP basics to you because IP addressing is an important part of networking. So why is it an important part of networking? Well, because IP addresses are used on any device that needs to connect to a network. So when you go into your browser and you type an address in, so for example, you go to the Pitt Community College webpage, you're used to type in the URL, which is a text-based version of an IP address. So what do I mean by that? Well, you go in and type in the http://www.pittcc.edu. And what actually happens behind the scenes is that that goes out to another server that translates that address into an IP address so that that physical device can be located on the network. And then the process starts with your whole OSI model, which allows you to be able to interact with that page or receive the information from that page. So I've put together a few notes for you that I hope will help clarify this a little bit and help you out. And I did this similar to what I would do in the classroom. So bear with me, this is the first time I've tried to do this for an online class, but I thought it might help a little bit. So here's a few basics. Now your IP addresses, they're written in a series of numbers. So you see the different numbers here. Okay. Each computer has a unique IP address. Okay. And they're written in what we call a dotted decimal notation. So this is an example down here. And you see where I have different classes of addresses. So notice my chart here. There's various classes. There's class A, B, C, D, and E. So what does that mean? Well, if we look at the range of each number, you'll notice, I'll make this a little bit larger so you can see it, but you'll notice that there are various numbers here. Now, each one of these is an octet. So if you'll remember from looking at binary, okay, there's binary numbers. So let me show you that. So if you're talking in terms of binary numbers, we're referring to either a 1 or a 0. So a binary digit is a 1 or 0. So what do I mean by a 1 or a 0? Well, and why do we use those? Because at its most basic level, that's all a computer can understand is a 1 or a 0. And why is that? Because they're electronic devices. And electronic devices operate under electronic pulses, which are series of ones and zeros. So each one of these is considered a bit. Now, because that's a really small unit of measurement, we don't often refer to things in the digital world as a bit. We usually refer to them as a byte. So a byte is 8 bits grouped together. And that's generally, we refer to a byte of information and then larger groups of information. So you could have a kilobyte, which is 1,000 bytes of information. You could have a megabyte. You could have a gigabyte, terabyte, petabyte, then it goes up to zettabytes, okay, for larger units of measurement. So you can have 1,000 megabyte would be 1 million. You can have a gigabyte, which would be 1 billion. You can have a terabyte, 1 trillion, and then so forth. So why are these units of measurement important in terms of IP addressing? Well, they tell us if you're referring to a byte of information, a little bit about the address. So each one of these addresses here is equal to 8 bits. So 192 is equal to 8 bits of information. 100 is equal to 8 bits of information. 32 and 3. So that makes your IP addresses a 32-bit address, or you could refer to it as a 4-byte address. Each one of these octets, that's represented in 8 bits, the ranges range anywhere from a 0 to 255. So 0 to 255. Now I'm going to flip back over to this other one that we were looking at. Now, if you look at the first octet for each one, so if I look at this one right here, notice this is a Class A address example. So the way your addresses work on the internet, corporations are assigned a block of addresses, and they're usually within a certain range. So like larger organizations may be a Class A range. So look at this. So a Class A address, the first octet would be anywhere between 1 and 126. So that's what makes this first example fall in a Class A category, because it begins with 100. The 100 falls in that range of 1 to 126. The Class B address example falls in the range of 128 to 191, making it a Class B address. Class C just follows suit here, so it's a 204, which falls between 192 and 223, so it makes it a Class C address. So why is that important? Well, the larger the class size, so Class A would actually have the ability to have more addresses. B would have less, and C would have even less. Now, if you look at the structure right here, what does this mean? N's and H's? Well, for a Class A address, this first octet, this 100, would actually be the network number. Okay, so I'll make that bold. That's the network number. So the network number would be assigned to that, that organization. For example, the way it would actually look here would be 100, and then it would be 0, 0, 0. Okay, and how do I know that? Because this is the default. So this would be what it would look like if it's not been changed. So if something is default, like you get a new computer or a new phone, so however it's loaded when you get it, okay, that's what we mean by default. So if you see a Class A address and it is a default address, the first one is the network number. Okay, all these others by default would be a 0, because that's the definition of a network number, is all zeros in the host portion of an address. So by default, the first octet would be the network number, the second, third, and fourth numbers would be host numbers. Okay, so let's look at a Class B. So with a Class B, you have the network host. So that means the 130.102 would be assigned to you. And then by default, those last two octets would be the host numbers. So 130, 102 would be network numbers. So what this would mean is this is what it looks like after somebody is assigned an address from their default. And then for Class C, the 204.211.28 would be the network number. And then the 11 would be the assigned number. The default network address would be a 0. Again, the numbers follow this right here. So for At Class A, the first number is the network number, the first 2 for Class B, the first 3 for Class C. And what that actually equates to is, for host addresses, see these 3 numbers right here? So if there are 8 bits in each one of these, then I have 3 of these, okay? So 8 plus 8 plus, or 8 times 8 plus 8 plus 8 is 24, okay? So I have 24 bits available to assign however I want to the computers within my organization. Here I have 8 and 8 is 16. So I have all of those to be able to assign, and then for here I have 8. Okay, now we have to figure out what are all the possible combinations that we could have with this set of numbers. Because more than likely you're not going to just want a number. Let's say, take for example the Class C address. You're not going to want to just number, well, 1, 2, 3, 4, 5. Because you could have how many numbers? If the numbers range from 0 to 255, okay, that 0 is listed as the network number, so you can't assign that. And you also wouldn't want to assign the last number, which would be 204, 211, 28. Again, those are the same because that's the network number. You can't assign that last number because that's what we would consider a broadcast number, which I believe you'll learn about in this section also. But the broadcast number is like a signaling that would be sent out to notify all the devices. Okay, so again, you can't assign the 0 or all zeros in the host portion. You can't assign the number that would have all 1s in the host portion as well. So what do I mean by that? Well, let's kind of flip over here and look at how that's done. Now, what we're using is a decimal address. Okay, I'm going to make this font a little bit smaller. So what we're using is a decimal address. So it looks like this. Here's another example of a Class C. So 192, 132.3. Okay, so we have to be able to convert these addresses. So you heard me talking about all 1s. You have to be able to convert these into binary numbers. Why do we convert those to binary numbers? Because that's its basic level. That's all the computer understands is 1s and 0s. If you've looked at your OSI model, you'll know that anytime information travels on a particular type of medium, it needs to convert into 1s and 0s. So if I'm looking at this and I were to see a chart here, why do we have this chart? Well, remember 8 bits in a byte, so when you're talking computer language here, you always start with a 0. So if I were to draw 8 bits, I'd have 0 through 7. So 0 through 7 is 8. And we're working in terms of binary. So we use a base 2 numbering system, binary, the 1 and 0. Now, the values of these, 2 to the 0 or 2 to the anything power would be itself, or 1. I'm sorry, it would be 1. Itself would be 2 to the first power, so that equals 2. 2 times 2 equals 4. Times 2 more would be 8. Times 2 more would be 16. Times 2 more would be 32. Times 2 more would be 64. And 2 more would be 128. Now, that is the value for each of these bit positions. Okay, so if you were to add all of these bit positions up, they would actually equal 255, and that's why the values have to range between 0 and 255 for each of these octets. So you actually calculate these using this chart. So how this works is that we take this first number, you do each octet individually, so 192. So if I wanted to calculate 192, this is the bit position, this is 128. So I'm going to put a 1 in the spot where I need that placeholder, a 0 where I don't need it. So 128 plus 64 would be 192. Okay, now because I have my 192, 0, 0, 0, 0, 0, 0. So that is the address for, oops, sorry about that. That's the address for this particular number. So 1, 1, 1, 2, 3, 4, 5, 6. So 192 equals this number. So if I were to do 100, can use the same, actually I'll add another column here. Hope that won't confuse anybody, but just for time's sake. So if I were to do the 100, I wouldn't need the 128. 64, I do need 64 and 32 is 96. Then I have 100. Okay, then for 32, that should be an easy one. Let's see, oops, it's so easy I went right by it. So that represents 32. And then for the number 3, let's see, I don't need any of these. And then 2 plus 1, okay, 2 plus 1 equals 3. So I'm going to make a column here. So this is the number 192. This was the number 100. This was the number 32. And this is the number 3. So all of these numbers together, I'm going to make this smaller so it can fit all on one page for you. Let's see. I'll make the spaces a little bit wider. Again, bear with me. I have not done this for an online class, so I am trying to kind of ad-lib here, so to speak. So for the 100, if I were to look at that, that equals, let's see, 0, 1, 1, 0, 0, 1, 0, 0. The 32 would be equal 0, 0, 1, 1, 2. And then the 3 would equal 0, 0, 0, 0, 0, 0, 1, 1. So that would be for the number 3. This would be for the number, whoops, 32. So if you were to put periods between each of these numbers right here, then this would give you the dotted decimal number. Now, if you wanted to convert in the opposite direction, you would do the same thing. You could take these charts and say, okay, so if this was the number given to you, the 11000000 here. So you say, okay, well I have a 1 in the placeholder of the 128. So I have that number. So I need to add 128 and I need to add 64 and that equals 192. And then you can go in the reverse direction. But this is just hopefully it helped you a little bit of an overview. If you have any questions, please let me know. I'll be making some more videos for you really soon. Thanks.